I'm Samantha.
And Maria.
And we're going to show you a Hardy-Weinberg equation.
So, it is used to find the frequency of alleles and genotypes in a population. We have two formulas for this, P plus Q equals 1, which is the allele formula, and P squared plus 2PQ plus Q squared equals 1, which is a genotype formula.
P is the dominant, big A. Q is the recessive, little a. P squared equals the homozygous dominant, big A. Q squared is the homozygous recessive, little a. And 2PQ is the heterozygous, which is big A, little a.
So, this is a problem that we have. You have sampled a population in which you know that the percentage of the homozygous recessive genotype, little a, is 49%. Using the 49%, calculate the following.
The frequency of the little a genotype. And since in the previous equation, when we were given the word problem, it told us it was 49%, we know that the answer is going to be 49% or 0.49.
Now, the frequency of the little a allele, Q squared equals 0.49 because it was given to us. Then you square root it and Q equals 0.7. Since we know that Q equals little a, then little a is going to be 70%.
The frequency of the big A allele. P equals big A. Since we already know, we found out that Q equals 0.7, we plug it into the equation of P plus Q equals 1, which is the same as P plus 0.7 equals 1, which then we move the 0.7 over, so it equals P equals 1 minus 0.7, which then gives us that P is 0.3 or 30%.
Now, one final part, it's the frequency of the genotypes big A, and big A, little a. We know that big A equals P squared, and big A, little a equals 2PQ. So we have this formula right here, and we know that P equals 0.3 and Q equals 0.7. So we find P squared here, we replace it with 0.3, and that's going to give us 0.9. So big A equals 0.9 or 90%. And then 2PQ is right here, and we replace the numbers and the letters, and it's 2 times 0.3 times 0.7. And so big A, little a equals 0.42 or 42%. Thanks for watching.
Thanks for listening.